Welcome to my mini tutorials. Today we're going to look at a thermochemistry chapter from the first semester. We're going to use Hess's law to determine the enthalpy of an unknown reaction. Well, it's a known reaction, but it's an unknown enthalpy. So we're after delta H for the reaction that I just circled. And of course, as you know, the easy way to do it is to go to the enthalpy tables and look up all the enthalpies of the products and the reactions and do the summation, but instead of doing that, we are going to use these four reactions here, and that's a lot, okay? And so there's a lot going on, so you have to pay a lot attention to everything here, and it can take a little while. Anyway, so we're going to use the enthalpies here, provided with them. So the first thing you want to do is you want to look at the reactants and the products and make sure they are on the right side. What I mean by that is that, for example, methane here, which is the only reactant, if we find methane here in reaction 2, we note that it already is on the reactant side, which is where we want it. So we don't have to reverse that reaction. If that reactant was on the product side, we would have to reverse that reaction. So, and which is the case for the products here. So I'm going to circle in blue the two products, the C2H4 and H2. So C2H4 in reaction number 3 is on the reactant side, but we don't want it on the reactant side because the reaction we're after has them as products. So we're going to have to flip this reaction. I'm going to go ahead and do that. So what I mean by flipping is you reverse it. You basically write it backwards. C2H6, which is a product in the provided reaction, becomes a reactant. And so now the products are C2H4 and hydrogen gas, which is the way they are written in the equation that we're determining, so that's what we want. So what happens is the value doesn't change for the enthalpy, but the sign does. So the delta H for this reaction is now plus 136.3 kilojoules per mole. And so if you find, as you know, look everywhere in the for products and reactants, because the substances can be part of several reactions here. And so here we go. We also have that in equation number 4. So we're going to have to reverse that as well. So H2O liquid goes to H2, and they left the phase label out. Not that that's important. Have O2. I mean, it is important, but not for this determination here. So we'll change the sign of that as well to positive 285.8 kilojoules per mole. So that's it if you look at it. And so what about this first reaction? Maybe they left it there for us to be confused, but most likely we're going to use it. So if we are looking for things in common, and so the first thing I see, I'm going to switch to black now, C2H6. And so C2H6 here is part of equation 3. Now we reversed that equation. So since C2H6 is neither part of the reactant nor the product, it's going to have to cancel. So if this is used at all, we will have to flip this. All right? Why? Because we flipped equation number 3, which is this, and so now C2H6 is part of the reactant. So if it's going to cancel, this has to be on the product side. So once I flip that over, and it's 4 CO2 and 6 H2O goes to 2 C2H6 and 7 O2. Alright, and so the delta H for that reaction, now we'll have to reverse that, is going to be positive 3,120.8 8 kilojoules per mole. So here I've cleaned up what we just figured out. These two reactions are reversed, and so are the signs, but now we have to look at the stoichiometry. And so we have, the first thing we notice is that we have 4 carbon dioxides on the reactant side, but only 1 here. So we'll need to multiply this entire reaction through by 4. And so that means we get 4 methane molecules and 2 times 4, so that makes it 8 oxygens, 4 carbon dioxide, and 2 times 4, again 8 water molecules. But we also have to multiply the delta H here by 4, so that's going to be negative 3,562.2 kilojoules per mole. Then we can look at the oxygen molecules if you wish. We have 8 on the reactant side, 7.5, so that doesn't work. But if we just simply multiply this last reaction through by 2, we can get 8 on the product side. So we get 2, 2, and then 2 times a half is 1. So again, we have to also double the delta H. So this is going to turn into plus 571.6 kilojoules per mole. And then the last one we need to look at is the C2H6. This is the ethane molecule. We have 2 on the product side in the first reaction, but only 1 here. So we'll multiply that reaction by 2, 2, 2, and 2. Again, we are also going to double 272.6 kilojoules. We're going to double the 136 per mole. So this should all now cancel out and produce this reaction. Again, let me go to a cleaner slide. Everything here in red is what we just changed, and so hopefully let's go through and see if everything cancels. We have 4 CO2s that cancel. We have 8 oxygens on the reactant side, 7 plus 1 that cancels. Methane is part of the product, so that's going to not cancel, hopefully. Let's take a look at water. We have 6 and 2, that's 8 water molecules. Let's see, we have 8 on the product side, so that cancels out. And so the last thing is that ethane molecule. We have 2 on the product and 2 on the reactant side. And so everything else should now come down, right? So what's left over is methane, and then we have ethene and then hydrogen. So pull it all down. We have 4 methane on the reactant side, and then we have, that produces 2 C2H4 in the gaseous phase, and then these two are the same, so that's 2 plus 2, that's then 4 H2 molecules. Alright, so that doesn't match the stoichiometry of the reaction above. However, we can now get the delta H for the way it is written by just adding this up, all of those, and so that produces 403.8 kilojoules per mole. Now we can just divide this by 2, and then we end up with 2 CH4 and 1 C2H4 and 2 H2, which matches the reaction above. And so we divide this by 2 as well, and so that the answer for active is, this is 201.9 kilojoules per mole. Alright, so this is the solution the way active has provided it. I hope this helped. There's a lot of little details to pay attention to. Get a hold of me if you still need some help.